Welcome back, everyone. Today we are going to talk about solving systems by substitution. So this is going to be Unit 3, Day 2. Now, in Unit 3, Day 1, we talked about solving systems by graphing. However, not all systems can be solved by graphing, so we have to use algebra. You can solve a system by using substitution. To solve by using substitution, you need to get a variable by itself in one of the equations. So here are the steps to solving a system by substitution. We're going to have a system where you need to choose one equation and solve that equation for x or y. This is going to be step number 1. Step number 2 is you substitute that expression into the second equation for x or y, depending on what you solve for in the first step. Step 3, simplify and solve the new equation. And number 4, substitute the value of x or y you just found into one of the original equations to find the value of the second variable. So our goal here when we are solving systems is to find the x and the y value. So let's take a look at number 1 here. We have y is equal to x plus 2 and x plus y is equal to 8. Remember, in step number 1, what we need to do is we need to choose one equation and solve for x or y. But if we look very, very carefully, y is equal to x plus 2. That equation is already solved for, right? It's already y equals, or sometimes it could be x equals. But in this case, it's y equals. What I'm going to do is I'm going to highlight this. And then I look at the other equation. I have x plus y is equal to 8. Know that if y is x plus 2, then with this expression here, I can take that and replace this y with that x plus 2. That's the whole substitution business that we're talking about today. So I have x plus, all right, so we know that that's originally y. But now I'm going to replace that y with x plus 2. And then equals 8. And this is where I'm going to combine the like terms. I have x plus x. That's 2x plus 2 equals 8. And I subtract both sides by 2 here. So I have 2x equals 6. Then we divide. So x is equal to 3. So if I already have the x value, then I can use that to plug into one of my equations to find y. I'm going to plug it into this equation here. If I plug in the x with this value here, that's going to give me my y value. So we have y equals 3 plus 2, and that's 5, right? So y is equal to 5, and then we can put this all in as an ordered pair. So that's going to be 3, 5. That is the solution to this system. Number 2, we have 2x plus y is equal to 6, and y is equal to 8x plus 1. Remember, on the first step, what we need to do is choose one of the equations and solve for x or y. But the second equation is already solved for, so what I can do is I'm going to highlight this and look at the other equation, that 2x plus y equals 6. I'm going to replace this y with this expression. So I have 2x plus 8x plus 1 equals 6. And then I'm going to combine the like terms. I have 2x plus 8x, that's 10x, plus 1 equals 6. Subtract both sides by 1. So I have 10x equals 6 minus 1 is 5. Then I'll divide both sides by 10. So x is equal to 5 over 10. But that fraction actually simplifies to 1/2. So x equals 1/2. So now we found the x value. What we need to do is find the y value. What I'm going to do is I'm going to take this x that we found and plug it into this equation here to find y. So y is equal to 8. Let's replace this x with 1/2. So it's 8 times 1/2 plus 1. So 8 times 1/2, or 1/2 of 8, is 4, plus 1, so you get 5. So, as an order pair, we have 1/2, 5. Number 3, we have 2x plus y is equal to 11, and y minus 8x equals 1. So, with this example here, none of the equations are not solved for. So what we need to do is we're going to choose one of the equations and solve for whatever variable we want. So in this case, what I'm going to do is I'm going to choose this equation, that y minus 8x equals 1, and I'm going to solve for y. So let's write y minus 8x equals 1, and then I am going to solve for y. I'm going to add both sides by 8x, and I get y equals 8x plus 1. So I don't need to use this equation anymore. I have y equals 8x plus 1 now. So we know that if y is equal to 8x plus 1, then I'm going to take this equation here, replace that y with that expression, right? The stuff that's after the equal sign. So I have 2x plus 8x plus 1 equals 11. Combine the like terms, I have 10x plus 1 equals 11. Then I'll subtract both sides by 1 here. So I have 10x equals 10. And then lastly, I'll divide both sides by 10 so I can get x by itself. So x equals 10 over 10, that's 1. So if x is equal to 1, then we need to find our y value. So we know that y is x plus 1, right? So I'm going to choose that to replace this x with this 1. So y equals 8 times 1 plus 1. So 8 times 1 is 8 plus 1. We get 9. So y is equal to 9. Therefore, as an ordered pair, your answer is 1, 9. And then lastly, we have x plus y equals 4 and 3x plus 3y equals 12. So let's choose one of the equations, solve for x or y, and then we're going to proceed from there. So I'm going to work with the most simplest equation that I can see here. That first equation, x plus y equals 4. And what I'm going to do is I'm just going to solve for x. We've solved for y for the previous problems. Let's change it up a little bit and solve for x this time. So I'll subtract both sides by y, and I get x equals 4 minus y. All right, so I don't need this equation anymore because I rewrote that as x equals 4 minus y. Now, if x is 4 minus y, I can replace this x with this expression here, that 4 minus y. So I have 3 times the quantity of 4 minus y plus 3y equals 12. And let's go ahead and use the distributive property here. So we have 3 times 4, that's 12, minus 3 times y, that's 3y, plus 3y equals 12. And notice we have negative 3y plus 3y. How many y's do we have? We have 0, right? So basically, these two terms cancel. So I'm left with 12 on the left-hand side of the equal sign and 12 on the right-hand side of the equal sign. So we don't have any variables. So no variables. We have a statement so there are two possible answers to this example here. It could be A, IMS, which means infinitely many solutions, or B, no solution. Now, if you remember, if the left-hand side is equal to the right-hand side of your statement is true, then we say that's infinitely many solutions. However, if the left-hand side is not equal to the right-hand side, then we say it's no solution. So, in this case, since we have 12 equals 12 as our statement, it is indeed a true statement. Since the statement is true, then we say that this has infinitely many solutions, aka IMS. Now again, if the left-hand side is not equal to the right-hand side, then we say it's no solution. So if this said like 6 equals 12, well, we know that 6 is not equal to 12, or 6 is not the same thing as 12. So we say that that is no solution.